Assalamualaikum warahmatullahi wabarakatuh and a very good morning to our supervisor, Dr. Sharifah binti Samsuri. My name is Adinadia binti Ismail from Group 27 and my group member are Khalicia, Jiawe, Ana Fahana and Nur Hidayah. So for today, we will be presenting our project Engineer in Security of BP Texas Refinery Explosion and Fire. I will start our project presentation for today with the introduction. So the BP Texas Refinery facility is the third largest oil refinery, which is located in United States, was owned by Ameco. So in 1999, this refinery was merged with Ameco, and after that, the BP Texas subsequently took over the operation of the plant. The explosion at the refinery was occurred on 23 March 2005 on Wednesday where killed 15 people and 180 people injured and resulting in financial losses exceeding $1.5 billion. So this incident happened during the startup of the isomerization ISOM unit where a raffinate splitter tower was overfilled, which caused a flare and then triggered the explosion and fire. Not only that, all the nearer facilities and houses were also damaged as far away as a three-quarter of the mile from the plant. So this incident is one of the worst industrial disasters in recent United States history.
Hi, I'm Hidayah. So for now, I will explain further on the unit and equipments that is involved directly in the incident happening. So basically, the main unit that has been involved in incurring the explosion and fire in BP Texas City Refinery is basically coming from this isomerization unit. So basically, in this refinery isomerization unit, or we can call as isom unit, is basically functions to convert and transform a low quality and a straight chain hydrocarbon into higher quality ratings of hydrocarbon that will be used and be employed for blending of gasoline and for other types of purposes. So basically, in this isomerization unit, you can see it is mainly comprising of a raffinate splitter tower here, and also comprising of the reflux drum, two heat exchanger, and also a blow down drum. So basically, the feed that will enter in this tower is mainly coming from aromatic recovery units, ARU, and then the hydrocarbon that will be entered here will be separated into a light and heavy hydrocarbon into the top and the bottom of the tower itself. So basically, as you can see here, at the top vapor, at the overhead line here, it is basically protected by three parallel pressure safety relief valve that is directly connected to a reflux drum. So in the meantime, it is also connected to the disposal collection system here, which is the blow down drum that is fitted to a vent stack that is exposed to the atmosphere. So now I will further explain on the incident description and the timeline on how the incident happened from the beginning until the end. So basically, the incident takes place in the morning and at the midnight of the 23rd of March at 2:05 a.m. So basically, after undergoing a period of maintenance process, the ISOM unit is decided to be restarted again to begin its operation. So basically, the startup procedure was actually not following a correct and strict procedures at the beginning, and also the personnel of the operation has pumped the liquid flammable into the raffinate splitter tower for about 3 hours without removing any liquid from the section of the ISOM unit. So basically, at that point, a false indication of the level indicators and also some faulty on the critical instrumentation alarm has also contributed to be the major factor that initiated the incident. So as a consequence, the raffinate tower, which is approximately around 52 meter, was overfilled very quickly, and the flammable liquid has been overflowed into the overhead pipe. So basically, the liquid has continue to run down to the pressure relief valve, which is 45 meters down, and the pressure at the bottom has been shoot up from about 21 psi into 64 psi quickly. So the three parallel valve was unfortunately opened and has been releasing an approximately around 195,600 liters of the flammable liquid into the blow down drum. So the blow down drum has the vent stack open to the atmosphere at that time, has and quickly has overfilled the stack and creating a geyser-like release out of the 34-meter tall stack. So basically, the flammable liquid that has been exposed to the atmosphere is very volatile and be evaporated very quickly, creating a massive vapor cloud, which is very flammable. So to add up to this issue of incident, there was a diesel truck that was located near to the location of the blowdown drum, whereby it has created a backfiring and also has been believed as the main source of the ignition for the explosion to happen. So basically, the explosion that was happened during that time have killed around 15 persons in that area and also injured 180 personnel that was mainly comprising of employees and also the contractors. So this incident is very devastating and has ended up as a very worst scenario up until now. So here is a few snapshots of the situation after the explosion has happened. This is the diesel truck that is believed to be the main ignition source, and this is the Texas City refinery situation after the explosion, and this is the snapshot of the explosion happened at the blowdown drum near to the raffinate splitter tower.
Hello, my name is Anafana and I will discuss about the environmental issues leading to the BP Texas explosion accident. As you may know, a refinery often causes air pollution and water pollution. However, BP Texas Refinery had caused major air pollution in Texas through their air emission. From the post-explosion inspection on BP Texas Refinery, the Environmental Protection Agency (EPA) found that BP Refinery had violated some clean air compliance by mismanagement of benzene, mismanagement of asbestos, and mismanagement of hydrofluorocarbon, or known as HCFC. Okay, the mismanagement of benzene comes from the refinery mechanical integrity issues and overdue inspection. Prior to the BP Texas explosion, the refinery failed to replace the ISO blowdown system with the flare system. Due to this failed ISO blowdown system, 18,000 of the toxic pollutant, including benzene, were released and caused severe air pollution in Texas. Meanwhile, the mismanagement of asbestos came from the BP failure to protect its employee from the asbestos exposure. The refinery had used asbestos as the insulator and drywall. However, BP Texas failed to maintain this insulation and caused asbestos to break down and release to the air. Last but not least, EPA had fined BP Texas Refinery for its mismanagement of hydrofluorocarbon, or known as HCFC. The refinery had used HCFC as the refrigerant in the refrigeration process and comfort cooling appliance. However, EPA suggests that BP Texas Refinery to replace HCFC with non-ozone depleting cooling material.
Hi, my name is Ho Jiawei, and I'm going to talk about the ethical issue of this incident. So, for this incident, the ethical framework that we use is actually deontology theory, where it stated that an action is morally correct if it satisfies a moral rule without looking at the consequences of the action. So under this theory, there are actually two principles that BP didn't follow. So the first principle is universality principle, where it stated that one should be doing on a maxim only if it is universally good and serve as a general law for everyone. The second principle is reciprocity principle, where it states that people should respect the rational nature of humans as free, intelligent, self-directing beings and should not treat other people as a mere means to their selfish ends. So on the next slide, we'll discuss about what mistake did BP actually made in terms of ethical lead. Okay, so the first one is they are not able to act rationally, where BP used full capacity equipment without assigning any well-trained supervisors and operators, and they also ignore the safety concern as well as industry standard that caused this incident, this explosion to actually happen. The second one is they actually had a bad communication among the operational personnel, which caused delay in operations and also in saving the incident purposes. Next, they are also not able to provide good working environment and also reporting culture, where they're actually not providing good environment to the workers, and also the upper level is actually ignoring the report from the worker, and the worker do not have any chance to actually raise their concern.
Hi, my name is Solicia Elisa Jitol, and I will be presenting on the recommendation parts of this project. To prevent similar accident from happening again, actions must be taken to address the environmental and ethical issues related to this explosion and fire. For the ethical part, first, BP Board of Directors should appoint a non-executive member with expertise in refinery operations and process safety to Board of Directors and the Board Ethics and Environmental Assurance Committee. BP Board of Directors should also ensure and monitor a healthy incident reporting program. Apart from that, BP Texas City Refinery should establish clear communication protocol to ensure the transfer of information during shift changes, conduct management of change for their organizational changes, and require the presence of competent personnel during particularly hazardous operation. For the environmental part, BP Texas City Refinery should consider the following actions, which are to evaluate the refinery process unit to ensure safe design of critical equipment, ensure safe operation through proper maintenance and testing of instrumentation and process equipment, improve their operator training program, ensure process data procedures are updated to reflect actual process conditions, and finally, to require additional board operator staffing during startup of process units and ensure that hazard assessment considers staffing level during abnormal conditions.
Last but not least, as for conclusion, so first of all, it is important to identify and also to define the safe operating limit for all mode of the operation. So based on the analysis, this incident occurred because BP Texas City Refinery did not develop a safe operating limit of deviation for high-speed tower level. Moreover, the isomerization unit did not address the upper operating limit for the raffinate tower level, causing the duration of the high-speed tower level were not recorded. Besides, the inadequate operator training for the operation personnel is one of the reasons that causing this incident to happen, where the operation did not train properly for the hazard of the unit startup, including tower overfill during the training. Therefore, environmental and also ethical issues play important role to prevent the similar incident from happening again in the future.